Hillside and Douglas. And I believe that is the Mercury, is that correct, John? And then there's Nathan. He did this using an iPhone and his 8-inch Dobsonian at Turkey Head. So we have that there. And then combining forces, we have Mercury there in this sketch that was made kind of between Dorothy and, where's Dorothy here? Dorothy and Nathan. So very good on that. And Bill Weir also sent me an email of his sketch, but I misplaced it. I couldn't find it there. So Bill was out at Machosen. We had people up at Mount Tommy. We had people in downtown Victoria. We had people at Peacock Hill, I think, looking. And there's another person on Glencoe Bay, is that correct? Glencoe Cove. And then at Turkey Head. So here's the group at Turkey Head, and they're holding cookies. These are cookies made by astronomer mom, Nathan's mom, Kathy. So we all had cookies there, and we had a raucous party. And wait a second, Dorothy?
Nathan made it.
Oh, Nathan made them. Oh, okay. Well, I stand corrected.
Look at all the blue sky.
Yeah, this was poorly situated. Yeah, but I think, you know, if we, in 2016, we had really nice weather for it. And we saw this little BB crawling across the planet. And I felt far more excited glimpsing it through Nathan's telescope here because it was such a challenge to see. And I was kind of buoyed up and victorious as I started home. So I think it really says that all of the people in the Victoria Centre who went out to see the planet, the transit of Mercury, they definitely have the right stuff. So congratulations. Now for announcements, I do have one announcement. At our latest meeting of the council, we got approval to buy a special encoder system for the Obsession 20-inch telescope. And what this will do is that we'll put these devices on the Dobsonian telescope, and we'll be able to register 2 bright stars in the sky that are separated by about 60 degrees. And then a little handset here is actually a specialized computer, and it will do the spherical trigonometry to figure out exactly where you're pointing, and you can go over 20,000 objects in this thing that you can easily find other objects once you've got 2 major bright stars registered. And this will actually, I think, enable more use of the beautiful 20-inch Obsession telescope. So that's that. And the Vice President doesn't have anything to say. I didn't see Bruce in here today, the editor. I will say that Bruce recently published another excellent article, or Sky News magazine, and he had quite a few interesting historical stories in there, so I encourage you to check that out. He's got, I think, a real flair for making the history of astronomy live. So great news there. Deb, treasurer? Thank you very much. Okay, membership, Chris.
Our current membership is 266, and there are 19 people whose membership has recently expired.
Okay, very good. Are they on the delinquent list?
Yeah.
They still have a chance? Okay. So if you're sitting on the bubble there, please renew. It would be appreciated. So we have next the school program, Sid.
Yeah, school program is going quite well. It's called Voyage of Discovery. We just discovered after Lori had her operation that we need 3 people to replace her. So David, Diane, and Chris for their help. And so far we've had 25 presentations and about 17 more to go.
But said we need somebody who can sing.
Yeah, definitely. Yeah, well, we got Diane.
Can you say sing? Yeah.
We have to sing for these great ones. And I am not a good singer, so it's my weakness. And yeah, so we need a good singing partner.
So
I'll bring my
this is
guitar.
the new criteria, or
It's a new kind of, yeah, that's-
curriculum, rather? Okay, well, the universe is expanding, yes. Very good, thank you, Sid. Technical committee, Matt?
Let's see, we did a new T point, and the collimation seemed to be good enough for most people's satisfaction, at least for shooting for the moment, so good progress so far.
Congratulations on that. The T-Point is a system that helps you find things in the sky through the computer. And they work really hard to get this thing back in operation. We're quite excited about it. So if you were interested in coming up to the Victoria Centre Observatory and having a look through this scope, you have to be a member of the active observers, on the active observers list. So please see Chris first if you're not on it, and then you'll be able to get up onto the hill. And the purpose of this restriction is due to the land use agreement that we signed with the National Research Council. Joe, website? Joe was actually put on a really great thing with the Mercury, transit of Mercury, a lot of information there. Thanks for that, a real resource, and appreciate that. Michelle's not here for the observing, and Nelson is not here for the National Council, so I won't go on with that. So upcoming events, as I mentioned, the Victoria Centre Observatory, we have sessions every Saturday, weather permitting. Astro Cafe opens its doors most Mondays at 7:30 p.m. and it's in a portable behind Fairfield Community Centre. And I believe there's planning to have a buy and sell or a swap meet on the November 25th meeting. And there is an opportunity for a STEM expedition at Glen Lamb and Northwick School. We participated in it last year, and
We are still deciding whether we can participate or not.
okay.
I need a good volunteers. If you don't get the volunteers, we may not.
Okay, so I will say I was there last year, and 3 things. One, the pizza was excellent at the games. The students were very polite, and somebody brought along a tarantula and stole the show. So if you've got any dangerous animals to bring along, please help us out. And next monthly meeting is December 11th, and it's in a room A104, this room. And Dr. Marcin Sawicki will be giving a talk. And it sounds kind of ominous, the lives and deaths of galaxies, more than just a metaphor. And I read the detailed abstract, and it's going to be a great talk, so I hope you'll make it out. John?
Just one little addendum before you get the buy and sell. If people have things that they would like us to know about and sort of do a little bit of pre-advertising, let Barbara Lane know, or Chris Purse, or myself.
So what tonight's speaker is Dr. Philip Stuke, and we'll set up your system now. And some time ago, Dr. Phil got, let's see here, you can put it there. He obtained his PhD from University of Victoria, and his specialty at the time was cartography, and he applied this to all these irregular shapes in the solar system. but he's done many other things. He's a planetary scientist, and he, for several decades, he's been back at the University of Western Ontario in that facility there. He has a specialty involving atlases of the moon and Mars, and he has accumulated a tremendous amount of information about the moon. And we were very fortunate to have him give us a talk tonight. So we'll hook you up for sound.
Thanks.
Can you say something?
Something. Perfect.
That's never worked before, and this is a new thing, okay?
All right, excellent.
Thank you very much.
Thank you. Yeah, it's a great pleasure to be here to speak to you like this. Many years ago, in the Jurassic period, I was a member of this centre as an undergraduate and a graduate student. And then I was whisked off to Ontario for 30 years, but now I'm back, supposedly retired, still doing lots of things. And so it's just really nice to be able to see everyone and talk to you today. What I'm going to do, well, I should say that this talk is actually slightly modified, updated from one that I did during the Apollo anniversary things earlier in the year. As I said, it's updated a bit, so if you saw that, it's not exactly the same. So we're going to look at what's happened at the moon, exploration missions to the moon since the Apollo era, and a little bit of extra focus on what's happening right about now and what will be coming up over the next few years. If you have a question about anything and you can attract my attention, I'm just kind of gazing off into the distance, I will be happy to try to answer questions as we go, but I'll also be around for the tea and cookies thing afterwards, and you can talk to me then as well if you like. So, okay, so Apollo went to the moon. We've just had the anniversary of Apollo 11 in the summer, and right about now is the anniversary, the 50th anniversary of Apollo 12. We've been thinking about Apollo in that context, but what did Apollo miss? Apollo didn't do everything, obviously. It missed lots of things. So in particular, it missed the far side, so the coloured image is a topographic map of the far side. The red areas are high, the white areas are higher still, going down to lower topography in the blues and greens there. And in particular, I've outlined a broad depression called the South Pole Aitken Basin. It has that name because it extends from the South Pole to a crater called Aitken, which is up near the equator, about 15 degrees south. So all of that was pretty much unknown to Apollo. We did have pictures of the far side, but they didn't really make it clear that there was a big depression in that area. It wasn't really understood until around about the end of the Apollo program. Apollo didn't look at the far side. It didn't look at any of the really large, very young impact craters like Aristarchus and Tycho. The youngest mare basalts, the big lava flows, it landed on middle-aged and older lava flows, but didn't see the youngest ones. It didn't see the oldest highland rocks, with all the highland areas they looked at were just covered with younger material thrown out by large impacts. So they missed the oldest parts of the crust. They didn't go and look at volcanoes or the sources of the big lava flows. They didn't go to the poles. They didn't discover anything about the water that we're now quite keen on learning more about on the moon. Everybody said for decades that the moon was absolutely bone dry, and all of a sudden they were saying that it was soaking wet. So actually, in a very modest sense, there is a little bit of water out there. I didn't see this funny-looking object on the right here, Ina, which was discovered during the Apollo program, but not very well understood, and only now with modern images do we know more about it. It's a funny-looking thing, a depression with these sort of blistery textures on the floor of it. The consensus now is that they're very young, sort of say 10 million years to 100 million years, which is young in lunar terms, and probably associated with the sort of the last gasp of volcanic activity on the moon before it finally calmed down. But actually, if it's so young, that does imply that there could actually still be a little bit of something rumbling away that could make a number of these at any time. But Apollo didn't see these things, so I didn't visit them anyway. So there are quite a lot of things that Apollo left undone. Why did they abandon the moon? Well, partly because of cost. Of course, Apollo was very expensive, if we think of it in terms of the percentage of the US federal budget in any given year, the maximum spending for Apollo was about 4% of the federal budget, which of course is an enormous amount, and now it's less than half of 1%, so about a tenth of that amount. So in that kind of accounting, there's a lot less money around for these things, so NASA had to withdraw from direct lunar exploration like that. But of course, other things happened too. The rest of the solar system, turns out, was found to be absolutely fascinating. These wonderful worlds with the moons of Jupiter here, one of them pulsing with volcanic activity, another one looking like it has an ocean under an icy surface, that sort of thing. And of course, other parts of the solar system, Saturn and its remarkable moons. We just recently had, a few years ago, those great pictures of Pluto showing it to be an extraordinarily complex and dynamic and interesting world. So the rest of the solar system drew people away from the moon. And then especially the search for life on Mars, which has consumed a lot of money and time. So lots of things were there to take people away from the moon. I should say something about the Soviet exploration of the moon. The Soviet Union sent lots of spacecraft to the moon. There wasn't really an enormous amount of science that came out of that. We had 2 rovers that drove around, one of them certainly holding the record for distance driven on the moon. It was Lunar 2. But they didn't really do a lot of science. They did a lot of driving, took quite a lot of pictures, but there wasn't an enormous amount of science that came out of them. And what did isn't necessarily available now. As an example, Lunar 2 had a magnetometer which measured the magnetic field data as it drove around. But it appears that that is no longer available. We don't know what happened to it. The data tapes are probably lost or unreadable. I have talked to people who've been through the state archives in Moscow looking for data tapes for the lunar cause, and they found imaging tapes, not magnetometer tapes. So the science may have been done, but may not be accessible, and there wasn't really a great deal of science then anyway. By far the greatest scientific contribution of the Soviet program was the sample return missions. 3 of them, they returned very small samples, but you can do a lot with a very small sample, so that's not really to put them down. Those have ongoing value today. We can still analyze and learn from those samples. But there wasn't really a lot of work, and in particular, the Soviets never undertook systematic remote sensing or spacecraft imaging of the moon. What happened, of course, then was Apollo left the moon at the end of 1972, and the last Russian mission or Soviet mission was in 1976. And then we had to wait until the 1990s to go back, so more than 1.5 decades. So lunar exploration continued in the 1990s with a series of relatively low-cost orbiters, to some extent experimental orbiters, which collected interesting new data sets. And the one that got the ball rolling was this one. It was a Japanese spacecraft called A10. science here. This was mostly the development of technology for space exploration and learning to operate at limited distances and those kinds of things. But they did carry a dust counter that collected some dust data from the area around Earth and the Moon. So that got the ball rolling in the very early 90s. Then in 1994, NASA got back into the fray. Not just NASA though, the logo lower left there. Oh, this logo shows Clementine was actually a Department of Defense and NASA mission. The Department of Defense had a bit of a problem. They had all sorts of fabulous sensors that could be used to detect missile launches, but they weren't allowed to test them. The Strategic Arms Limitation Treaty prevented them from testing these things in orbit. So they said to NASA, how about we fly to the moon and we can use our sensors to map the moon, and in the process we'll learn lots about what they can do. And you get some moon data. So Clementine was a mission that was run by both agencies. And it imaged the surface of the moon more systematically than had ever been done during the Apollo era. They had a laser altimeter that collected topographic data. So this is the topographic map. Again, sort of red and white is high, and the blue and purple is low, as in the earlier map. And it's really worth pointing out that we did not have global topography for the moon during Apollo. They had stereo images that would give you topography for landing sites, but there was no adequate global topography, certainly nothing for the far side. So this Clementine data set was the first global topographic data set we got. Very valuable, very useful thing. It certainly showed the existence of that basin, although it had been detected in limb profiles from a couple of earlier missions as well. But this really showed the extent of it at that time. They did a bit of measurement of chemical composition. This is the titanium map, showing that titanium is concentrated in the Mare areas, the dark basalt lava flows that they concentrate on the earth-facing side of the moon. So they collected some information like this. Yeah.
How can they detect the presence and abundance of titanium?
These things were the moon with a very short time delay. You could drive with a little joystick kind of thing, just directly driving on the lunar surface, which is what the Russians did with their lunar pods. So they could achieve long drives because they're driving almost in real time. The longest drive ever undertaken in one work shift on Earth was 3 kilometers by lunar cod 2. And the longest that this thing has ever driven is about 20 meters. So there's a bit of a difference there. But it's because it's a different way of doing things. They have an infrared spectrometer which points at the area that is outlined in red as a camera, and an infrared spectrometer, so the camera shows you what the infrared spectrometer is looking at. And the field of view of the spectrometer is this. So this just is an illustration of how they tried to get a spectrum from this rock. They saw the rock in the distance, and actually that's the rock right there. So they're over here, about 5 meters away. They see the rock and they decide we're going to go and look at that. And they drive up to it, and now the field of view, well, it's not quite pointing at the rock. The problem is the instrument is fixed on the front of the rover. So if you can kind of picture the rover, it's driving along, and this thing is fixed, and you drive along and you have to kind of turn a bit, and you can turn this way and go a bit closer, and finally you're looking at the thing. But if you're not looking quite, I think what you have to do then is sort of turn a little bit more. They turn a bit more, and then they have to go forwards a bit, so now that point is up on the rock. So it takes a bit of manoeuvring, and if you have to manoeuvre quite a bit like that, you don't necessarily get many of those observations in a lunar day. But that's what they've been doing, and they've got quite a lot of good stuff from that. So they are sampling this South Pole Lake and Basin material in the ejecta of the crater nearby. The crater has thrown the ejecta into where they landed. This is a map of their path. That's the landing site. This is actually the spacecraft casting a shadow there in a lunar reconnaissance orbiter image. And they've driven like this, blah, 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 for 11 months. Right now, they're in their 11th night. So they've driven for 11 days, 11 lunar days, and they're in their 11th night right now, and they're here a full 218 meters from where they landed, having driven a total of 320 meters on that path. Now, they survived 11 lunar days, and that gives them the record for the longest operating rover on the moon. The previous record was held by the Soviet Lunokhod 1 in 1970-71, and it broke down during its 11th day. So because this survived to the end of its 11th day, it's actually the record holder now. But in that time, it's driven 320 meters approximately, whereas Lunokhod 1 drove 10.5 kilometers. However, I have to say that this mission has done an awful lot more than Lunokhod 1 ever did in terms of generating science. We have dozens of measurements of composition, soils and rocks, and impact melt, stuff like that. Lots and lots of measurements like that. Ground penetrating radar. It's a much more productive mission than the Lunokhod. Okay. And once upon a time, there was the Google Lunar X Prize with lots of teams, these are just some of them here, that were supposed to compete for a big prize to land on the moon. And that fizzled out, but it left a few teams still planning to do something. And one of them was the Israeli team, Space IL, where IL is the internet country code for Israel. This lander Bereshit was launched earlier in the year. It crashed in April. Didn't quite make it safely to the ground, but it did get to the moon and get to orbit. Take some pictures. This is where they were going to land in Mare Serenitatis, the Sea of Serenity, and this is Clementine false color again. They were going to land here in a magnetic anomaly, and the spacecraft was equipped with a magnetometer to measure the magnetic field during its descent and on the surface. And during the descent, they're flying at low altitude towards the landing site, And apparently they did collect and transmit data during that period. And I hope that we'll actually learn something about the results of that, maybe at a big meeting next March down in Houston. So nothing has been said about it yet. But there may be a bit of science from that. And then they crashed, and this is a lunar reconnaissance orbiter image of the crash site. And since then, we've also had another crash, Chandrayaan-2, India's second mission to the moon. It has an orbiter, which has been very successful and operating very, very nicely in lunar orbit. But it also had a lander and rover, and unfortunately, the lander crashed, and we're still trying to get a picture of it from the lunar reconnaissance orbiter. It's taken several pictures, but not seen the lander yet. So it might have been a bit more off course than they had anticipated. But the orbiter is doing well. This is a synthetic aperture radar image with a variety of data sets used to color it. So we're getting good data from the orbiter. But it's very early days yet, and not very much has been released about that. Next year there'll be a sample return attempt. This is Mare Imbrium here, and that's the Bay of Rainbows, Sinus Iridum. Chang'e 3 landed there, Chang'e 5 will land here, and a young lava flow. And if they collect that sample and return it to Earth, it will be the youngest lava flow ever sampled on the moon. By youngest, I mean about 2 billion years old. That's what they're aiming for. And then later missions are supposed to be going to the South Pole. Over the next few years, we're going to have quite a few more landers in the Commercial Lunar Payload Services program. NASA basically paying to fly instruments to the moon, and the spacecraft that carry them are also free to carry payloads from other entities as well. This is a company called Astrobotic out of Pittsburgh, which has been working for years on this as part of the Google Lunar X Prize, and eventually withdrew from the competition, but they're planning to fly in 2021 with a whole group of NASA payloads as well as some payloads from other people. So hopefully they will succeed. Intuitive Machines is a Houston company trying to do the same thing, and again they have a contract with NASA to fly in 2021 with NASA instruments being carried. Orbit Beyond grew out of an Indian team called Team Indus, but the Commercial Lunar Payload Services program isn't available to non-US entities. So Team Indus had to team up with an American company to provide hardware and so on, but they're flying under the American flag in this case. But they hope to go in 2022 probably. And maybe in the next decade, or possibly, sort of wrapping things up here, Project Artemis, about which much has been said. NASA's plan originally was to go to the moon in about 2028, but the Vice President, Michael Pence, who's a very keen space guy, decided to really try to speed that up by urging them to get to the moon by 2024, basically the end of a second Trump administration, if such a thing exists. So that was the plan, and that was mandated about a year ago, but it's not at all clear that there's any money for this. So we don't really know what will happen. I don't think people will get to the moon in 2024, but I think 2028 is doable. However, there was a very recent meeting, only a couple of weeks ago, looking at a possible plan for the first landing. This would be the Artemis 3 mission. Artemis 2 will launch at the end of next year, or more likely in the spring of 2021, without a crew, and will fly the spacecraft called Orion around the moon and back to Earth to demonstrate navigation and a safe return and so on. It will drop off some CubeSats and other little spacecraft that will do things around and near the moon. Artemis 2 would take people to the moon, but not to land. And Artemis 3, in the current scheme, would land in 2024. Like I say, I don't think that will really happen then. But here we are at the South Pole again. So this is the rim of Shackleton Crater. Shackleton Crater there. That's the South Pole right on the rim. This is part of the connecting ridge that runs through to the Gerlach Crater, which would be sort of over here. And they're anticipating a landing on the ridge with the idea that you'd have 2 astronauts on the moon for 6 days, and they would have a little rover that they could drive around. They would be in an area that was fully illuminated for those 6 days, but with the sun almost on the horizon, so any little depression would be filled with shadow. And what they would do is drive to, not to all of these places, but to some of them, the little red spots, which are permanent shadow areas, which might contain ice and other volatile materials. So they would explore some of them and try to sample that material and analyze it. So this is a thought about what might happen with the first landing coming up, although I think it's more likely to be in about 2028. Okay, well that's the end of my presentation. We covered a lot of ground there, but if anybody has any questions, you can ask them that or up in the lounge, whatever you like.
Well, that was fascinating. John, you get the question?
Yeah, two questions I've always wondered about. Whether the new information sheds any additional light on the difference between the side of the moon that we don't see and the side that's close to us, because they certainly appear very different. And I've read different explanations for why that might be, but I don't know if there's a really definitive answer.
Right. Well, I think the best answer to that is no, there isn't a definitive answer. Some people have suggested that the crust on the Earth-facing side is much thinner because it was originally removed by a gigantic impact, and that would predate the South Pole Aitken Basin. It would strip the crust away from the Earth-facing side and deposit it on the far side as ejecta, and that would produce the dichotomy. But there's no evidence in the Grail gravity data for the existence of that impact.
So that sort of leads into the other question. You already partially answered it. What do we know about, what's the latest on the origin of the moon?
Right. Well, the popular idea at the moment is that the moon is the product of a very large impact on Earth. So an object that would perhaps be about the size of Mars, with 10% of the mass of Earth, strikes the Earth and has to be an oblique impact when you do the dynamical modeling. You have that oblique impact, a huge amount of material is thrown out from Earth and from the impactor, and it coalesces in a big mass around the Earth and eventually forms the moon. That works much better than earlier attempts to explain the moon as a result of capture of an object. You can't capture something, it just doesn't work like that. Or somehow breaking off the Earth because the Earth got spinning so fast that a piece broke off. You can't make that work either. This idea of the impact works better, but it doesn't solve all the problems, and there are still details to be worked out about how the moon ends up with the exact composition that we observe, and exactly how the dynamics of that work. And there are various versions of this floating around that people are still playing with, but we haven't settled on an explanation that answers every single question about the moon yet.
Thank you.
Yes, all right.
And when you showed us the far side of the moon, the Aitken's Basin, there's an area of high elevation just above it. Is that the ejecta from Aitken's Basin?
Yes, it is. We think that the South Pole Aitken Basin impact was oblique because the basin is somewhat elongated, and the ejecta would be primarily piled up downrange. But there's some in the other direction as well, which actually is the Southern Highlands on the near side. Yes?
Is there any factual basis as to where the origin of the basalt rock is? Not on the moon, it's an igneous rock.
Yeah.
Might have been part of the
Earth ejecta, the crust hole was ejecta, and originated here and settled there.
No, that doesn't work. And it doesn't work because of the time period involved. Now, if we go right back to the beginning of the space age, there was a scientific giant stalking the halls at NASA and lots of other places, Harold Urey, telling people that the moon was a primitive body that had never been processed in any way, and you wouldn't find volcanic rocks on its surface. He believed that there had been no geological activity since the formation of the moon. And his opponent in a big debate about this was Gene Shoemaker from the US Geological Survey, who thought that there had been volcanism and lava flows and so on. And he amassed evidence to show basically that there had to be a substantial period of time between the formation of the big impact basins that contain lava flows and the lava themselves, the lava flows themselves. So there's a period of time there between the earliest history of the moon and the formation of the lava flows. Now we have Apollo samples, we can date that very clearly. So basically, those lava flows that were sampled by Apollo 11 and Apollo 12 and so on, they are 1 billion years after the formation of the moon. So you can't rely on the molten material from the initial formation of the moon forming those lava flows. It's 1 billion years later that the lava flows appear. Okay, so, yeah.
One piece of science that's been continuing since Apollo were the retroreflectors.
Yes.
Are they still shooting them, and is there interesting science coming off that?
Well, yes, they're still being used. The thing is, the retroreflectors may not be changing, although I gather that some of the signals are getting a little bit weaker, perhaps because a little bit of dust is building up on them. But they're still being used. But the important thing is that our instruments on the ground are getting much better, and so we're getting better data than was ever available before. Especially so you can do very, very fine time slicing of the return signal, so you can get the distance to the moon much more precisely than before. So initially, the data that we got from the reflectors was just about the exact distance to the moon, and then you watch that over a period of time, and you can map out the moon's orbit and so on. But now we're able to look at slight small movements of the moon, physical librations and so on, and the amount of those, and they tell us something about the internal structure of the moon and the degree to which mass is concentrated to the center. So we're sort of demonstrating the existence of a lunar core, of denser material, that sort of thing. However, they would still like to have more reflectors. So actually on the Bereshit Israeli lander and on the Chandrayaan-2 Indian lander, both of which failed, there was a NASA reflector, which would have helped to expand the range of those reflectors. Ideally, we want to have reflectors near the limbs and the poles to get a much better handle on the way the moon moves physically. Yeah.
So Phil, you showed a lot of pictures of spacecraft that have either landed or impacted on the moon. Did you participate in the search for any of those, or?
Yeah, that Chinese one was my discovery. I have a paper in Icarus about it. The Smart 1 impact was mine. There's another paper about that. I've got something in Icarus more recently about the Apollo 12 lunar module ascent stage. The lunar module lands on the moon, and the top part of it comes back. And when you don't need it anymore, you crash it on the moon to make a seismic signal for the seismometers that are deployed on the surface. And we're in the process of finding those impacts. So I have something on Apollo 12, which has already been published. And right now I'm trying to find the time to write up something on the Apollo 14 lunar module impact. So yeah, I have been involved in that.
Wow. It was 50 years ago tomorrow that Apollo 12 took off its voyage. So it's kind of a neat celebration that seems to keep on going here over the cycle.
Yeah.
And I know, I was interested because Apollo 11 overshot their landing site significantly. I read that in Apollo 12, they factored in the local variations of gravity from the mountain ranges and that. And it landed so close that it was very close to Surveyor 3. And they were able to go and take some devices off of that had been sitting out there and being bombarded by cosmic rays. They brought back a camera, and they found inside the camera lens bacteria still growing, and that fostered the theory of panspermia, that life can be transferred from outer space and survive descent through the atmosphere and that.
Yes, now I don't want to rain on your parade here, but the people who did the analysis of the surveyor pieces that were brought back say that they accidentally contaminated that. They're on record saying they contaminated it.
Yeah.
So we can't believe that.
I'm not emotionally destroyed. I was but I know that this generated a kind of almost like a conspiracy theory. You hear a lot of those things. But at any rate, that was great. So Phil recently retired, and last year he retired. And I asked him, well, what, are you still active? He said, oh yeah, I'm as busy as ever, but I don't get paid anything. So in token of your appreciation for your giving us the time and expertise here, we have this coveted glass that...
I shall covet it.
Yeah, it's got James Stanley Plaskett's image on it, and this was in the 100th anniversary of the Dominion Astrophysical Observatory, and the beer was called Big Dipper, double IPA. I found that pretty much any beverage that I've drank out of this type of glass tastes better. So I hope you.
I only get the glass, not the beer.
Oh, gee. Big oversight.
I'm not coming up to the lounge.
Yeah. So
Okay, thanks.
now. Two things that I forgot to mention. Chris Peirce brought out these Sky News, and now some people who are new to are just coming for the first time. You're most welcome to take one of these magazines. If you get a membership, you receive one of these magazines mailed to you as one of the benefits. The other thing is I guess we're going to be having an annual general meeting on February 22nd, so you'll be asked about what sort of banquet food items that you want, and we'll be getting a message out sometime in December area, something like that, I think so. And a reminder that you're welcome to join us up in the 4th floor astronomy lounge for cookies, coffee, and conversation. So thank you for